Good morning. I'm Laura Barrera, Managing Editor of No-Till Farmer, and I'd like to welcome you to today's webinar where we are going to examine how cover cropping systems can impact and be an asset to your nutrient management plans. Today's No-Till Farmer webinar is sponsored by Crosse Seed, the producer of Soil First cover crop seed, and here to help us learn more about the role of cover cropping on nutrient management is Scott Wohltman, a certified crop advisor and agronomist for Crosse Seed. Before we turn things over to Scott, there are a couple of things we want to make you aware of. On your screen, you will find an orange box with a white arrow inside of it. Click on that and it will open up a question field that will allow you to submit questions at any time during the presentation. At the end of Scott's presentation, we will look to answer as many questions as possible in the remaining time. If for any reason the webinar is disrupted or you seem to have been disconnected from the webinar, just go back to the invitation email you received and rejoin the webinar through the web link in that email. With those housekeeping items out of the way, the No-Till Farmer team wants to thank you for joining us today, and we will turn the controls over to Scott. Good morning, Scott. How are you today?
Good, Laura. Thank you so much for the opportunity to be on the call this morning. Like I said, my name is Scott Wohltman, the Eastern Cover Crop Lead for Crosse Seed. For those of you that don't know, Crosse Seed has been in the seed business since 1947, and we certainly understand there are numerous challenges and nuances of this ever-changing cover crop industry. I'm from and live in Illinois, but this morning I'm actually talking to you from Pennsylvania. As a certified crop advisor, I do see a lot of things around the Midwest and around the Corn Belt, and perhaps probably more importantly, I hear and talk to growers and ag professionals every day on both the good and bad experiences with raising cover crops. It's safe to say we are always learning more concepts and gaining a greater appreciation for how cover crops are being utilized and integrated into production agriculture. Because Crosse Seed primarily distributes our products to ag input suppliers and seed dealers, we happen to get exposed to, I would say, many challenges facing the agricultural industry, from nutrient management strategies all the way over to water quality initiatives, and just we hear a lot about sustainability programs. The purpose with today's webinar, though, is we're not going to dig into corporate responsibility, or we're not going to mull over long-term fertilizer standards, but we're going to focus on a few basic topics concentrated on nitrogen that our team at Crosse Seed often gets questioned on. And as I considered what topics to present today, I really thought it made sense to focus on some of the main questions we're getting this time of year from the field. With that, here are the main points of this presentation today. With that, here are the main points of the presentation for today. First, we're going to talk a little bit about how much N is fixed by cover crops and when it can be expected for the next cash crop. We're going to talk a little bit about maximizing N production and understanding nitrogen immobilization and mineralization. We're going to hit on the role of inoculants in cover crops and why they are important. And also we're going to talk about cover crops for forage. And yes, nitrogen obviously plays a role in that as well. Again, these topics for some might be fairly simple and old hat. For others, it might be something relatively new. But again, these are some of the questions that we're getting from growers today. You could literally, if I had all day to talk, we could talk for 2 days straight on the many ways that cover crops and nitrogen impact each other, but I think these four are a pretty good place to start. So let's get into predicting nitrogen delivery. And this is probably the #1 question we get every spring is how much N am I getting from my cover crops and when will it be available? This slide from that we've kind of compiled with averages from Kansas State, Colorado State, and Penn State shows typical N contributions from some of the more traditional cover crops that are being used today. You can see a huge difference not only from one legume to another, but also with the range given to each species. The obvious reason for this is because there are so many factors at play. I think it's worth to say that understanding the variance with this points us to understanding how legumes fix nitrogen in general and how they turn atmospheric nitrogen into usable forms that plants can actually utilize. I think everyone understands that legumes fix nitrogen. About 79% of the air is nitrogen gas. However, that gas is not, or that nitrogen is not in a form that plants can use. Legumes don't actually remove nitrogen from the air. Rather, the rhizobium bacteria, which live in small nodules on the root of the legume, those bacteria actually take nitrogen from the air in the soil and convert it into ammonia, or NH3, that then is converted to ammonium, NH4, which the plant can use. This fixation is somewhat of a symbiotic relationship. And what I mean by that is the rhizobium bacteria gives the legume plant nitrogen in the form of ammonium, and the plant in turn provides the bacteria with carbohydrates for energy. So the rate of N fixation is directly related to the legume plant growth rate. You can assume that anything that would take away or discourage from how that plant grows would likely take away from how much N is fixed. And what I mean by that would be anything like drought, disease, potash availability, and then also low temperatures. Low temperatures is really a big influence on nitrogen fixation. There's been some research done with several different clovers, and kind of that optimum, and that research has been from coast to coast. That optimum temperature is somewhere between 55 and 80 degrees Fahrenheit to fix nitrogen. Now, as we go on either side of that range, the rate declines drastically. So again, because there are so many, we're back to the slide that we showed earlier, because there are so many factors at play, that's kind of why we use the assumption that only about 50% of these totals can actually be utilized by the next crop. And if you look at the green box, there are other things at play also. So if this cover crop is harvested for grain or forage, we remove a huge portion of the nitrogen that was fixed. And we'll get into this in a second, but plant material and biomass is actually what helps fix nitrogen, or creates nitrogen available in the plant. With the right cropping system and or livestock system, a lot of that N can be recovered. But again, of the totals that you see here on the screen, and there's a wide range, we need to assume that only about 50% of this N will be available. Like we've discussed already, a key benefit of legumes is their ability to supply plant available nitrogen, or PAN, for the following crop. The PAN, or plant available nitrogen, provided by a cover crop can replace purchased in inputs like fertilizer or manure. But to take full advantage of the plant available nitrogen, or this benefit, it's useful to know how to predict the value. So in general, green leafy plants, and we're thinking of, kind of think of a green manure type scenario, green leafy plants and plant tissue have higher N concentrations and a higher PAN than ones that aren't as vigorous or don't have as much biomass. Carbon and nitrogen relationships kind of control the release of plant available nitrogen. As soil organisms decompose residues from the cover crop, a portion of that cover crop carbon is lost from the soil as carbon dioxide. The remaining cover crop carbon is transformed by the decomposition process and yields what I would call fresh soil organic matter with the CN ratio, carbon-nitrogen ratio. We'll talk about that more in a minute too. That fresh soil organic matter has a carbon-nitrogen ratio of approximately 12:1. That N percentage in a cover crop is strongly related to plant available nitrogen following cover crop incorporation. So for legumes like hairy vetch, we'll just talk about hairy vetch, that are high in N, and hairy vetch has a percent N in dry matter somewhere between 3 and 3.5% usually. About half of the N is released as plant available nitrogen because the cover crop, in this case hairy vetch, has more nitrogen than needed to build soil organic matter. They can provide up to 100 pounds of PAN. So the second bullet point there, legumes can provide up to 100 pounds of plant available nitrogen, but in order to get that, they really need to be controlled or terminated at bud stage, or even early flower stage or flower, to realize that benefit. On the other hand, other cover crops, like non-legumes, like cereal rye, for instance, let's just say cereal rye that would still be in stem elongation growth period would probably be about 2% nitrogen. Once that small grain reaches a heading stage, that percent nitrogen in dry matter drops to about 1%. So anytime that falls around 1% in dry matter, plant available nitrogen is actually immobilized or made negative. What happens is the cover crops decompose more N, or as the cover crops decompose, more N is required to build soil organic matter than what is available or present in the cover crop. So there's two ranges here going on. Legumes can provide quite a bit of PAN, whereas cereals have the ability to immobilize or make negative the amount of nitrogen that's out there because they need more N. Because more N is required to build soil organic matter. But overall, total nitrogen as a percent of dry matter is a good predictor of plant available nitrogen. So as we think about how do we figure out how much N I actually have out in my field, really a good way to do that is taking total N as a percent of dry matter. With most low carbon nitrogen crops, like a legume or other broadleaves, most plant available nitrogen can be released in 4 to 8, maybe even 10 weeks after the cover crop is terminated. If we look at the chart here and we do the math, every 1% of N in dry matter equals 20 pounds of N per dry matter ton. But because of what we mentioned earlier, the lower the percentage of N in dry matter, the longer it takes to achieve that plant available nitrogen release. In the case, I've made the upper and lower green. In the case of covers with a 1% N in dry matter, even after 10 weeks, if we go all the way over to the right-hand column, even after 10 weeks, the plant available nitrogen wasn't measurable on 1% N in dry matter. And I just put on there rye because in a lot of cases, rye that is headed out is at that 1% level. On the other hand, cover crops with a higher percentage of N in dry matter, like let's say peas or hairy vetch, the plant available nitrogen totals are way more apparent early on after termination. So when we talked about earlier that only 50% of that N could be available, we look at the pounds of N per dry matter ton on peas at 3.5%. That's 70 pounds of N. After 10 weeks, 37 pounds, a little over half of that, is made available. So that's where some of that 50% comes from as well. So when we talk about measuring dry matter or taking these measurements of percent N in dry matter, that's actually taking a live sample of cover crop biomass from the field. So there's several different ways to do that, but typically what guys are doing is they're going out with a 1 foot by 1 foot square like a metal frame or something made out of maybe a PVC. Maybe it's 2 foot by 2 foot, but usually they're doing it in a relative scale, and they're going out and they're dropping that to the ground, and they're harvesting all of the biomass that falls in that square, and they're doing that several different areas throughout the field, and taking a relative sample. But from that, then you cut all of the crop away except for any cover crop that would be kind of pushed down in the dirt. We don't want to get any dirt in the sample, and you weigh that, and then you send it off to a lab, and then you're going to get these results back. Typical results, or typical labs that I've worked with or that I know that do this, are going to charge somewhere between $20, $25, maybe $30 to $35 a sample. But guys, in order to get a real read on where we are, how much N we have out in our fields, this is a surefire way to get that done. And just so everyone understands the differences, this table illustrates the kind of the variance from grasses to legumes within a typical N contribution. So I've been talking about vetch and peas, and if you look at hairy vetch and winter pea, that percent N and dry matter is about 2.5 to 3.5%. But I do want to make note that these estimates did come from Oregon State, and they were taken in Oregon, Pacific Northwest. So keep in mind that temperature and rainfall can have a fairly large impact or influence the numbers provided. So this is just kind of a place to start, and I think it's a good table that you can reference. And again, this information comes from Oregon State. It's really good. Our team uses it a lot, and I think it's something to kind of give you a head start. But if you really want to figure out how much N is out there, we really need to take a sample. The picture on this page shows a crimson clover field in central Indiana that was overseeded or interseeded into V4, V5 corn. So again, if a guy wanted to go out and take that sample of that, he could sure do that, weigh it, and come up with a kind of a prediction on what that's actually yielding out there. So as we circle back around to the C/N ratio, or the carbon to nitrogen ratio, I think it's critical to think through crop rotations and understand that when these cover crops are terminated, there will be a drastic difference in the cover crop carbon, and that will dramatically alter how quick those residues decompose and desiccate. I think we all understand that legumes and brassicas will have a much higher level of nitrogen and thus a lower C/N ratio versus small grains and crops with more of that can tend to have a more woody residue as they mature. This ratio is much higher. So you can see rye straw and corn stover and oat straw way up top. You can get C/N ratios that are really high up there compared to hairy vetch and even vegetative ryegrass. I know some people think of annual ryegrass as something that is can be a struggle, but vegetative ryegrass can have a very small C/N ratio as well. So why is the C/N ratio so important? We did mention the word immobilization earlier. So cover crops with a C/N ratio higher than 24:1 will undoubtedly need additional nitrogen for the next cash crop, depending on what that cash crop is. These residues, when incorporated or added to the soil, result in a nitrogen deficit or immobilization, because again, more nitrogen is needed to balance out the carbon than what is available or present in the cover crop. On the other hand, species with a C/N ratio lower than 24:1 will result in a temporary nitrogen surplus or mineralization, meaning they produce more nitrogen than what's needed to build soil organic matter. Ultimately, what it means is this: the larger the C/N ratio, the slower the rate of decomposition, which means that nitrogen and other nutrients could be tied up if it's not managed properly. So the picture here is a cornfield seeded, planted into cereal rye. This field looks pretty good. I would assume, I don't know this firsthand, but I would assume this field got quite a bit of starter fertilizer. It didn't look like the rye was necessarily controlled super early, but the corn is off to a very good start. The second bullet point there, terminating grass crops in the vegetative stage is recommended when you're going to any kind of crop like corn or soybean or corn or sorghums that use a high rate of nitrogen. So we'll talk about that next. And this is another big question that we get is, can we plant corn after a small grain cover crop? And if we reference Dr. Hartzler from Iowa State, there are still many, many challenges attributed to planting nitrogen-loving grass crops like corn after a small grain cover crop. Most people refer to it as an allelopathy, where what that means is basically where chemicals by one plant inhibit the growth of another. Whereas typically we don't think of rye residues as being 100% responsible for the release of toxic chemicals, research has shown that allelochemicals can present obvious problems. But usually they present problems to seeds that are much smaller than corn. In the case of corn, it's fairly large seeded, and because it's planted 1 inch or sometimes a little bit deeper than that in the soil, it might be a little bit more resistant than some smaller seeded crops. But corn is kind of on the radar, and for good reason. We do see a lot of issues. This is a picture of a cornfield in Illinois, close to where I reside, that is coming up quite nicely in a rye field. The rye was burnt down, and then as it started to desiccate, it just kind of fell all over the place. But so far, so good in that field. But we can have challenges for sure. So again, referencing Dr. Hartzler, several factors may be involved. I think the way out, or the safe thing to do is to blame the allelopathy involved with rye. But if we think through this a little bit, rye mulch on the soil surface can alter the environment in a way that inhibits the growth of corn. The mulch can definitely delay soil temperatures, or warming soil temperatures, and drying, and we can only imagine how that can create a less favorable environment for corn. One way around that is to think about using row cleaners, which I know a lot of growers are doing already, and other planter attachments that remove that mulch from the seed bed or from that furrow, and also eliminate kind of some of the hairpinning that we see oftentimes with planting any kind of seed into a standing or even a worked field of cereal rye. Second point, rye may act as a green bridge. So I definitely think that in some cases, the dying rye can serve as a host for other pathogens that move into to corn seedlings, and that can cause a problem. So I think that's definitely something to think about. However, I would say one of the things as it relates to this presentation that we see a lot is that decaying rye biomass can easily tie up nitrogen in the soil. So that nitrogen is very much needed by that early corn crop as it gets started growing, for sure. So I think looking back on, to summarize, planting corn after small grain cover crops, it can be done. We can look at allelopathy, we can look at other causes, but I think one big thing is make sure you manage the residue, and then obviously plan ahead with your nitrogen, because that biomass can tie up soil in. So what's that mean? At planting corn, you're probably going to have to put a starter fertilizer on for sure, 2x2 or something to make sure that corn does not have that corn is not in a situation where it faces a deficit early on. let's talk a little bit about inoculants. So not without knowing where everybody on the call is from, I will say that for anyone out there that's raised any kind of a legume crop like alfalfa or soybeans, it's fairly common knowledge that rhizobia bacteria inoculants are a crucial component to allowing the legume to properly fix large amounts of nitrogen. But what do we do about our cover crops? Do we need to inoculate the cover crop? Without the correct rhizobia present, a cover crop legume will not maximize nitrogen production, and the result of that is the benefit for our corn the following year, or any kind of grass crop, will not be achieved. So cover crop legumes need rhizobia, and if we do not have the proper background population in the soil, we must inoculate. The problem, or the challenge, is most of the common cover crop legumes, including all the ones listed there, winter peas, crimson clover, hairy vetch, sun hemp, you name it, really do not have a viable option to pre-inoculate like alfalfa or red clover does. So, and what I mean by that, for example, is the rhizobium that nodulates alfalfa can survive on seed for 2 years or more. In many cases, though, other strains outside of alfalfa don't last on seed for much more than 24 hours. So the point here is beware of pre-inoculated cover crop seed, because in most cases there will not be any surviving rhizobia. Let's dig into that a little bit deeper. So just to look at some of the lifespan of some of the strains needed to properly inoculate, let's look at soybeans. So we talked about them a little bit. If you're using a liquid inoculant, and again, I assume most of the people on the call are experienced with soybeans, using a liquid inoculant that contain an extender, they're good for quite a while. Even a sterile peat product for soybeans are good for 30 days. But a standard planter box product would only be available for 2 or 4 days. Move that to alfalfa or red clover. Clay pre-inoculants for alfalfa are good for, like we said earlier, 2 years or more. Those same clay pre-inoculants that we put on red clover would be good for about a year. But peat-based planter box products are only good for about 48 hours. And as we look at crimson clover, and here might be a shocker, some of the pre-inoculants that we would put on crimson clover are really only viable for about 48 hours. And even hairy vetch and winter peas, in a planter box treatment, again, kind of going off the theme here, they're not going to last very long at all. So to me, the take home is crimson clover. The industry, we've been using crimson clover as a cover crop for a long time, and I think this is where some of our traditional thinking may need to be reconsidered. For some time, the industry has promoted pre-inoculated crimson clover, but that inoculant simply isn't viable very long. And in the case of larger seeded cover crops, like we mentioned before, they just don't last very long either. So we believe in adding fresh inoculant at the time of planting, because that's the only way to ensure the rhizobia will be living and doing what they need to do. A handful of manufacturers produce different strains needed by all of these different cover crops used today, and those can all be purchased individually. However, there are also some new products on the market that make the process of inoculating mixes of cover crops, or let's just say a cover crop cocktail that contains one or multiple legumes in it. There are products that make that a whole lot easier. So I'm not going to go into a commercial spiel, but if you want more information on some of those products, you can go to our website and get that. The take-home message here with inoculants: if we don't inoculate, if we don't have a viable background population of the strain that we need in the soil, we're going to have to inoculate. And as we think about the windows that we face in the fall, and the windows a lot of times to get stuff seeded and get cover crops established are not very long. Anything that we can do to get our cover crop legumes off to a good start, I think we should consider. And inoculant is definitely one thing to keep in mind. Let's talk about cover crops as forage. So we don't have the word nitrogen in there, but you're going to see how nitrogen obviously plays a big part. This field of cattle was taken from Nebraska. They're grazing in a field, I believe, that is radish and potentially triticale out there. I'm not sure on what the small grain is, but I think cover crops as forage make a lot of sense. There's no better way to make cover crops pay in their first year than to feed them. And I think we could all assume that just about anything could be fed. But it's important to match the goal of what you're trying to do to the species or to the product. And what I mean by that is some work better, some products work better to be grazed, others would work fine cut as silage or baleage or anything like that. So we're talking about cereal grains in a lot of cases because they do make a lot of sense. They're very simple and they supply a lot of tonnage. But if tonnage and biomass is the goal, then everything should be done to achieve it on the end of the grower. What I mean by that is planting date. Make some changes if you have to make some changes to your cropping system to ensure that cover crop gets seeded as early as possible. Maybe you're going to take a cutting or a grazing in the fall. You need to make sure that planting date is addressed. Again, the ideal use of the forage, silage versus baleage versus pasture. And then you guessed it, understanding the fertility needed. And a lot of times growers are looking for cover crop for forage, but they might not necessarily know how much N to put on or how much P and K to put on, or maybe they don't put any on at all. And if that is the goal, different from maybe a different role or a different goal with a cover crop, if you know that forage and creating biomass is the goal, then we need to add fertilizer. Cereal grains, again, I won't read through all of these, but you probably picked up already that there's a trend on how many times we've mentioned the word small grain or cereal rye. They are extremely popular cover crops across most of the country, and they also make great forage if they're managed properly. But and you can see wheat, fall, trit, winter barley, cereal rye. A lot of these are being used at different parts of the country, and they really, really work good. Again, with some of the livestock markets that we have today, it probably does make sense to start utilizing even some of these cereal grains a little bit more for forage, especially if you haven't used them before. They're not that hard to get incorporated, and they make a lot of sense. However, and there's a picture of some fall rye being chopped in May in Illinois. However, you have to keep them fertilized. So I've got a few things here, just a few examples of just going off of removal rates for wheat and rye as silage. And if we're going to say that's equivalent to a 60 bushel wheat crop, now in some areas, I'm sure some of the people on the call today are raising much higher yields than 60 bushel per acre. Maybe others, maybe not so much. Maybe that's right on. But if we're going to use the equivalent at 60 bushel as a base, you're going to need 80 to 100 units of N, 40 pounds of P, and 60 to 70 pounds of potassium. For oats, if we want to look at an equivalent of an 80 bushel yield crop, the N would be a little bit less, and the P would be a little bit less, but the potash would be substantially more. And I think we all have seen how brassicas respond favorably to additional nitrogen and phosphorus as well. When a radish crop or a radish field starts turning lime yellow or lime green or kind of a putrid color, we can assume that all of that nitrogen that was out in that field has been successfully scavenged by that radish crop. So brassicas do definitely respond favorably to additional nitrogen and phosphorus if the goal is to use them for forage. In the case of summer annuals and forage sorghums, they also make a lot of sense. They're ideal for filling that summer gap. Perfect for after wheat harvest if it's maybe too late to double crop another crop after wheat. Forage sorghum or summer annuals work really good. Sometimes in prevent plant situations, they work really good. They take advantage of heat and dry weather, and they do it in a short amount of time. So they're forage sorghums, there's sorghum Sudan grass, there's straight Sudan grass, there's pearl millets. But one thing to keep in mind is summer annuals and some of these sorghums are fairly inefficient users of nitrogen, and they do require additional management, especially, again, nitrogen. Forage sorghums, like a one-cut forage sorghum or a multiple-cut sorghum Sudan grass, need approximately 1.25 pounds of actual N per day. So if we're thinking about, a lot of times we hear for sorghum Sudan, you plant it and in 40 days or 40 inches, you're going to be cutting that the first time. So do the math, 40 days times 1.25, you need to put about 50 units of nitrogen out there at planting. After you cut that crop, because it's so inefficient, you're going to have to put more in out there and do the math again. So that's one thing about summer annuals. And again, a lot of times these summer annuals are utilized as a late season, early fall cover crop. That is one thing to keep in mind. The one thing about nitrogen in a lot of these cover crops, though, that we also need to consider is nitrate levels. So this is a real concern that I have across all the areas that I cover. We hear a lot about nitrate levels being high in forage. We also hear about prussic acid concerns. I truthfully don't see a lot of prussic acid issues in livestock, but I do hear of nitrate levels being a huge problem, and I've seen that firsthand. Expect nitrate levels in some of these cover crops to be higher whenever there was excess fertilizer applied or manure that was applied that maybe was just put out there in excess, or maybe the plan wasn't to put a cover crop out there and they were just put a lot of manure out there and now we're going to feed it. That could have a higher nitrate level. Sometimes, a lot of times, the way that nitrate levels increase in plants is when fertilizer or any kind of fertility is exposed to these summer annual or any of these cover crops, followed by a period of stress, like drought or frost. The nitrates in those plants can rise to levels that may take several weeks or even a month or two to dissipate. I'd like to say that nitrate levels are only found in summer annuals like sorghum Sudan and pearl millet or something like that, but actually they can be found in just about all of the cover crops that we use across a good part of the country. From small grains to summer annuals to radish, turnips, rapeseed, we can find high levels in just about everything. We can use some common sense to reduce the probability of nitrate issues. Typically, nitrates are concentrated more in the lower stalk. So if we can raise that cutting height, we can reduce the risk. I will say that once you cut that crop or cut that plant, it does retain the nitrates, don't have anywhere to go. They're stuck in that plant. So if at all possible, if you think that there's a concern, it's best to leave the plant in the field and then cut that forage once those levels have dissipated. You can kind of help control high levels of nitrates by including feedstuffs that are high in carbohydrates like grain, like corn, and that helps reduce the effects of nitrates. Like we said earlier, you probably will have to delay harvest at least 1 or 2 weeks, if not longer. This goes back to managing nitrogen. If we can consider split applications of nitrogen, nothing new than what we're hearing today with some of the nutrient management plans that are out there. This makes a lot of sense from a nitrate level. Also, if you think there's a concern, we need to expose livestock slowly over several days into a suspected pasture. And again, make sure if you think there's a concern to test that forage ahead of time. It's better safe than sorry. And finally, again, there are a million different topics and ways we could go here, but we're talking about manure, and we talked about manure as it could lead to potentially high nitrate issues. This probably, the whole idea behind manure probably lends itself to a whole other webinar, but there's been a lot of work done and current work being done in Iowa, Pennsylvania, Michigan State is doing a lot of work with manure and cover crops. Canada, without citing all of the data, we're seeing that cover crops can definitely reduce nitrogen emissions and soil inorganic nitrogen losses when manure is applied. So having some sort of a small grain or a grass component in there can really help manage that nitrogen. Not only that, but small grains alongside manure applications have decreased NO3 losses in drainage water as well, whether that is surface drainage water or that is tile drainage. Again, a lot of data out there that backs up that for sure. We get questions a lot, our team does, on what cover crops work best with certain different kinds of manures. From what I've seen traveling across the Midwest, annual ryegrass is very tolerant to swine manure. It also does very good in poultry manure, and I've even seen it utilized very well in dairy manures as well. Clovers do a fairly good job, whether it's crimson red or even Racine clovers. They respond very well to just about any kind of livestock manure. And then brassicas, I think there's still more work to be done here, but depending on how the brassicas are seeded, whether it's before the manure or after the manure has been applied, radish and turnips tend to do a pretty good job. I think there needs to be some more testing here when it comes to brassicas, because sometimes they can be a little bit more difficult. But in general, radish and turnips do, I would say, better than average, especially turnips in hog, poultry, or cattle manures. Obviously, though, cover crops probably needs to be more work done to pinpoint cover crop and manure interactions and how that works within a nitrogen mineralization. Like I mentioned earlier, Michigan State is doing a lot of work with manure slurry seedings. They've been doing that for well over 10 years, and they've been seeing some very positive results as well. So if there are folks on the call that would like to get more information on, I think this manure thing, I think as we go further down the road of nutrient management in areas of the country where there's a lot of livestock, managing manure is going to be it's already a huge deal, but it's even going to get more critical. I think the manure component is going to be a thing that cover crops can really play well with. So if not only on manure, but if any of the data or things that I've referenced, if anybody wants more information after this call, they can for sure get a hold of me at my email address there, which is swohltman@blackseed.com. So again, I want to say thank you very, very, very much for the opportunity to be on the call today. I wish all of you guys a very successful summer and a successful 2016 crop year. And there's probably a few questions potentially. So if there's time for questions, I'll take a few. Thank you.
All right. Yes, Scott. Thank you very much for taking the time to present all that information. That you certainly covered a lot of the material. And we do have some questions that came in, so I'll just kind of go through them. One question that we had was about using cover crop mixes after applying hog or beef manure. And I know you just talked about using cover crops with manure. When you said using small grains alongside manure, do you mean seeding those before application or after? And do you have any suggestions on whether a cover crop should already be established when a grower makes a manure application or not?
It's a great question. So the research that I've seen uh, coming up from the north, whether that's Michigan State or Pennsylvania or Iowa, a lot of guys are seeding cover crops with some sort of a Gandy seeder or a Valmar seeder along with putting manure. So they're doing it at the same time. If that's not the case, and I know Michigan State's actually using it in slurry, and the benefit of that is that you don't have to work the ground. You can lay that slurry right on top of the soil. The seed is mixed with that slurry. It works pretty good. Now, understanding that not everybody has that machinery or that kind of equipment. If it was me and what I've experienced across the country is most people are applying the manure first, and I go that might not necessarily work with everybody's rotations and in their farming system. But if you can apply the manure first and then somehow lightly incorporate or no-till drill that seed into that after the manure application, that has had better results than the other way around. What you can't control, depending on how you're spreading the manure, is you can get some pretty thick residues out there that, depending on the cover crop, might not necessarily work uh, real great either. It kind of also, I know it's a long-winded answer, but it kind of goes back to looking at what cover crops can handle variances in salt and pH, and that kind of goes into play here too. The cover crops that I listed all do a fairly good job, but in extreme cases where you know levels could be alarmingly high or something like that, we probably need to look at another alternative.
All right, great. Another question we have is when working with summer annual mixtures, including high amounts of legumes, is additional nitrogen required?
I think that's a good question. I think it all depends on if it's for forage or not. So if you're using a summer annual legume with some other summer seeded crops, and the goal there is biomass or things, weed suppression, just other goals besides actually um, for forage. My thought is, especially if there's a legume in there, that you probably do not need to add additional nitrogen. Now, if you're in an environment where you know that there's very little soil or very little nitrogen left in the soil, and the crop rotation lends itself to adding more nitrogen in the soil for the next crop, then potentially that's something to consider. It all depends on, and we hammer this home quite a bit, it all depends on first figuring out what your goal is. Farmers and growers and everybody that works with them and helps them first we need to realize and understand what our goal, what are we trying to achieve, and that's one. Two, can I integrate that into my farming system without making a lot of changes? And three, if the answer is no, I have to make some changes. Really willing to make those changes? And one of those changes might be adding supplemental nitrogen. In the case of the question, if there's already a summer annual legume component included in the mix, then depending on your goal, you might not have to add any nitrogen.
All right, great. And kind of as a follow-up to that, how does frost termination of legumes the previous fall affect nitrogen availability in corn the following spring?
So if I understand the question, the you're going to frost seed, or it's going to be it's going to be terminated.
It's going to be terminated by frost.
Okay, so terminated. So it was seeded the following year. Frost terminates it. So it all goes back to how tall and how much biomass was out there of that clover. If there was sufficient, if it was seeded early, maybe it was seeded in the summertime, and that legume was allowed to flower or get close to flowering. That's obviously going to have a bigger impact than if you seeded, let's say, crimson clover in September, and it was only allowed to grow for 3 or 4 weeks, and then winter weather terminated that crop, and it was only a few inches tall. There's going to be a big difference there. So if you're utilizing, you're going to plant a legume, and the goal, maybe it's not the goal, but maybe it's a secondary benefit, is to get a little bit of extra nitrogen. Unless that plant, you need to do everything in your power to maximize the growth and the biomass on that plant. Because the more biomass, just like we talked about earlier in the slides, the more biomass and the further along with that growth rate, the more plant available nitrogen we're going to have for that next crop. A lot of times, I'll just say last point, a lot of times we add legumes in mixes where probably we might be wasting our money because of the time that we're getting them seeded. So just think through that. If you know that the time isn't going to allow for adequate legume production, then probably makes sense not to even put it in at all, unless unless potentially you're in an area where something might overwinter by chance or something.
All right, great. This next question is about using Solvita tests to validate the benefits of cover crops on soil health. Have you done any work with that test or the Solvita SLAN test to see how cover crops affect soil health? And do you have any comments on that?
Yeah, so good question. Solvita, we got the Haney test, we have the Cornell test. There are several new tests wrapped around, probably more centered on soil respiration, that all do a good job. They don't all necessarily test the same thing. So my remarks would be that anywhere that you have exposure to them and you want to test that on a fairly small, or a fairly large grid level, I would encourage you to do that. But the challenge with those tests today they're very, very expensive. I think as we continue to go down the road of this and cover crops become even more, when you use the word mainstream in terms of how we look at soil fertility, then potentially the cost of the Solvita test and some of these other tests that you referred to will get a little bit more economical, and I think then we can start using them in a smaller grid size across many more environments. But they are useful. They definitely have a place. Our company hasn't necessarily partnered with anybody on those, but I myself, and I know many guys on our team, have dealers and retailers that have been using Solvita to try to pinpoint where, kind of gives us a starting off point on where we're at, and then we can something to track. It's just another tool in the toolbox. I think as maybe if we're talking again in 2, 3, 5 years, I'd like to think that the cost on those will hopefully get a little bit more economical. But they are very worthwhile ways to look at soil respiration.
All right, great. This next question, the person asking is a little concerned about terminating cereal rye and allopathy with the following corn crop. Does the leachate from terminated cereal rye act as a germination inhibitor to the corn seed? If you have any thoughts on that, Scott.
Yeah, so good question. We did hit on that a little bit in the presentation. So the whole idea behind allelopathy is that a real concern? I would say today it's hard to pinpoint exactly, and I'm not going to make that statement here today on this call that allelopathy exists or it doesn't exist. Rye can obviously, there can be some allelochemicals that are produced by the mulch. There's no doubt about it. But like we said earlier, it's about controlling that residue. If we can control, because that's where all of this comes from, if we can control that residue, again, goes back to the plan. If the plan is that you want to go to corn after rye, but you want to use rye because of the benefits that rye gives, that's fine. But just plan to terminate that rye early. And along with that, make sure you've got the tools in place, whether that's the right row cleaners or other tools on your planter, to get that residue, away from that germinating corn plant, because we don't necessarily have all the answers. I referenced Dr. Hartzler from Iowa State, who's done a lot of work on this. I still think, though, that there's a lot of work yet to be done. But I think we use allelopathy as a crutch and say, oh, it's just an allelopathy issue anytime that the corn has a struggle into rye. And that definitely could be part of it, but I don't think it's telling the whole story. And I think managing nitrogen and managing that residue is a bigger part of it.
All right, great. One grower is wondering if he applied 20 to 30% of his nitrogen and phosphorus corn fertilizer to a winter cover crop, would those nutrients cycle after decomposition? What are your thoughts on that, Scott?
Well, it depends on the cover crop. Depends on the timing of when that fertilizer is put on. It depends on the weather, the rainfall, climate after that fertilizer is put on. So could a percentage of that nitrogen, so you put your fertilizer on, you have a cover crop out there, is that cover crop basically going to hold on to that in and make it usable for next year? There's not a doubt in my mind that there's going to be a percentage of that fertility that will be useful and will be made available for that next crop. Because of all the factors, though, I can't necessarily pinpoint what that's going to be. So to make the assumption that all of that fertilizer or that commercial fertilizer that's put out there, all of that benefit is going to be realized, next spring. I don't. Too many factors involved. Will a cover crop, the right cover crop, help? It can definitely enhance that, but the wrong cover crop could definitely turn that the other direction.
All right, and I think this is probably going to be our last question as we're almost out of time, but someone was wondering whether they should use starter fertilizer when seeding cover crops. Do you have any recommendations on whether they should do that and if it's with certain cover crop species or not?
So starter fertilizers, typically we think about that with our cash crops. If you're going to put a starter fertilizer down with a cover crop, I assume it's because of your planting window and the goal. It goes back to the goal. If the goal is biomass and you need, as much root biomass or above ground biomass or forage in a short amount of time, and you think, given what your soil currently has out there, isn't going to be adequate, then I definitely think it makes sense to add a starter fertilizer or any kind of fertilizer at planting, without a doubt. If the goal is just to latch on and try to scavenge any leftover nutrients that are already out in the field, then it doesn't make a whole lot of sense. Again, it goes back to the goal to put a starter fertilizer on, because your cover crop's going to sequester those nutrients that are left out in the field anyway. So again, Laura, it goes back to the goal, and it kind of goes back to the planting window and the crop rotation.
All right, great. Well, we are going to wrap up today's webinar, but before we conclude, just a heads up that when you log off today, you will receive a questionnaire to complete. It's simple, easy to complete with a small number of questions, and your answers will help us determine the value of today's webinar and also help us with planning for future webinars. Second, we will be making available via email to you a replay of today's webinar in the event you'd like to go back and review the entire presentation or some parts of it. You'll also find that replay of the webinar up on our No-Till Farmer website shortly. There's a webinar archive section at no-tillfarmer.com where you can go back and listen to previous webinars. Finally, any questions that we didn't get to this morning, we are going to share back with Scott to answer, and we will post those with the webinar replay as soon as they are available. I want to thank Scott for leading this discussion and thank Crosse Seed for sponsoring today's panel and making things work flawlessly. I also want to thank today's producer, Cole Vandermels, for running the control panel. To all of our no-tillers attending today, we hope your crops are looking great. Please watch for an announcement shortly on an upcoming webinar next month. Thank you for joining us today, and take care.